Hello everyone, I'm Chaitanya Tandon from Team Lip Parties, and I want to present to you a revolutionary deep learning based silent speech recognizer, LipSense, which aims to not only redefine privacy and enhance accessibility, but also to shape the future of human computer interaction by capitalizing on the modalities of visual communication. The field of speech recognition has witnessed significant advancements over the years, with a focus on auditory input for deciphering spoken language. However, speech is not always an effective form of communication under different circumstances. Firstly, someone might be in a noisy restaurant or close to a crowded market where it is difficult to understand speech, an environment which is not conducive to speech based communication. A person could be in a public place where others don't want to be disturbed, like a library or a museum, and not want to talk out loud. There could also be worries of privacy and confidentiality. Finally, and most crucially, a large number of people struggle to talk or are completely speechless as a result of a variety of neurological and speech impairments. The purpose of this project is to engineer a sophisticated and accurate silent speech recognition system by means of a fusion of three-dimensional convolutional neural network and gated recurrent units. This system has the potential to not only augment the quality of life for individuals with hearing impairments, but also to transcend to diverse domains where audio data may be compromised or unavailable. We leverage the spatio-temporal characteristics of lip movements and then the sequence of three-dimensional convolutional neural network layers and gated recurrent unit layers, and finally the connectionist temporal classification loss categorizes the lip motions into a array of characters which we have defined in the vocabulary, and then the raw tokens are decoded to give us the final prediction of what is being spoken as a sentence. This project has been developed as part of IBM Hack Challenge 2023. We have used IBM Cloud and IBM Watson Machine Learning API client for easy deployment and management of a machine learning model. We chose the grid corpus dataset for training our model due to its sentence level and extensive nature. The sentences spoken in the dataset have a very structured format: a command, a color, a preposition, a letter, a number, and an adverb. The architecture of a model has three spatio-temporal convolutional neural network and spatial pooling layers, two bidirectional gated recurrent unit layers, a linear layer, and a connectionist temporal classification loss function to finally categorize the lip motion. The total trainable parameters are approximately 85 lakhs in number. The performance metrics are very promising. The LibNet architecture that we have used for developing our app, when trained on the entire grid corpus of 34,000 videos, outperforms some of the best human lip readers by 4.1 times. It has a remarkably low word error rate of just 4.8% and an unseen character error rate of 6.4%. So let us try this out for ourselves. So we can choose among a set of videos which the model has not seen before. That is, a set of videos which the model has not been trained upon. So we can select a video, play, and check what is being spoken. The model is making its prediction. The model has successfully predicted what is being spoken. This video is passed to the model without the audio. The model is mapping the sequences of images as a sentence through the architecture I described before. The video is first pre-processed, the lip region is cropped and converted to grayscale. There is standardization by um, getting a zero mean and unit standard deviation. This is done to reduce the computational load. The output of the machine learning model gives us a sequence of tokens, which are decoded as words. So the final prediction that the model made was set wide at SE again. The model is predicting the lip motions at the character level, not at the word level. This eliminates the need of segmenting the sentence into words. The previous models were limited in this aspect that they were making predictions as words, which greatly limited the application of the model into sentences or words which the model was not trained upon. But this model is trained to recognize characters, not words. So even if the model is being given input of words it has not been trained upon, it could predict the word by predicting the characters. The person had spoken set white in U7 again, and the model did a remarkably well prediction given the limited amount of data it was trained upon. So let us try it out for some other video. The model is predicting. The model has successfully done the prediction set white in O1 soon. So this is an extra character because the model is not predicting words, it's predicting characters. So we've used IBM Cloud and Watson machine learning services for deployment and management of a model. The web app has been created using Streamlit. We've used OpenCV for video processing and TensorFlow for primary designing and training of a machine learning model. This application has numerous possibilities. In the future we could integrate it to recognize other facial expressions. We could develop a module to calibrate to individual users for more personalization and accuracy. We could also develop a mobile application which could uh, enhance the accessibility of this app on the go, and people with disabilities and speech impairments could uh, easily use it. You can also add a light enhancement module to mitigate the challenges posed by varying lighting conditions. You could also train it on different languages for multilingual support, and that could potentially facilitate cross culture communication. This model can also be used greatly to reshape the human computer interaction in the entertainment and gaming industries. The computer could also uh, we could also enhance speech recognition modules by combining the outputs which we get from the visual communication cues from lip reading and facial expressions with what we are getting from the auditory input. This could potentially greatly enhance the accuracy of speech recognition. I invite you to imagine the possibilities and join the lip reading revolution. This is Team Lip Buddies signing off.